problem number 4, catastrophic cancellation. This is something that's very similar to one of the previous homework problem, and as a matter of fact, as far as programming part is concerned, that is part B is concerned, there's essentially not much difference. You just need to calculate the given function in a couple different ways at these given x values, and we all know how to do this efficiently without using any loop. Okay, and you can tabulate the result using either this or fprintf. I've already shown you how to do that in the previous installment of weekly supplementary video. So here I will just briefly talk about how we should understand this scenario. Okay, so here we begin by recalling that log of c, okay, has a Taylor series expansion of c minus 1 minus c minus 1 square divided by 2. So we can write that as 1/2 times plus 1/3 times c minus 1 cubed, and so on and so forth. Okay, so so when you have log 1 plus x, okay, then if you think of this as c, you see that c minus 1 is nothing but x. Okay, so I can write down the Taylor expansion of this as x minus 1/2 x squared plus 1/3 x cubed, and so on and so forth. Okay, so this is something that we learn in calculus. By the way, to remind you, everything starts from the geometric series formula. So 1 divided by 1 minus x is equal to 1 plus x squared plus dot dot dot. So if you do 1 over 1 plus x, you get 1 minus x plus x squared minus x cubed, and so on and so forth. Okay, and if you do term by term integration, okay, so if you do term wise or term by term integration, okay, the integral on the left hand side, the antiderivative of the left hand side, is simply log 1 plus x. You can quickly confirm it by differentiating this derivative of log. And keep in mind that in this class, log means ln, natural log. You get this. Okay, so let's differentiate, so we confirm that this is correct, meaning that integral of this is equal to that is correct. And let's do term by term integration. Okay, antiderivative of 1 is equal to x. Antiderivative of x is x squared over 2. Antiderivative of x squared is x cubed over 3. Dot, dot, dot. And you'll have, say, plus c here. But by plugging in x equals 0, okay, all these infinite terms go away. But on the left-hand side, you have log 1, which is equal to 0. So that means that c has to be equal to 0. Okay, so this is calculus 2 all over again. Okay, so either way, we know that this is true. Okay, so now let's establish the continuity of the given function of f, f at x equals 0. Okay, so what does it mean for a function to be continuous? Okay, recall the definition of continuity. Definition says that f is continuous at a if and only if limit as x approaches a of f of x is equal to f of a. Okay, so that's what it means for a function to be continuous at a point. Okay, so in our case, we have to show that log 1 plus x divided by x when x approaches 0 should equal to 1. Okay, so when you take limit of this as x approaches 0, you should get 1. Okay, so that's what I'm going to show you. So we need to show that limit x going to 0 of log 1 plus x divided by x is equal to 1. Okay, so that's what we need to show. This is f of 0. But using the Taylor series, log 1 plus x divided by x is equal to x minus 1/2 x squared plus 1/3 x cubed minus ... all divided by x. Well, if you like, you could have used sigma notation. Sigma, say k going from 1 to infinity, x to the k divided by k with alternating sign. So -1, 1 to the power of, say, k minus 1. That would do. Okay, but it's not that complicated, so I just wrote first several terms out. And if you do the algebra, you get 1 minus 1/2 x plus 1/3 x squared minus, and so on and so forth. Okay, and what I'm going to do is just to stick in limit symbol. Okay, so limit x going to 0, limit x going to 0, limit x going to 0. Okay, so this is calc 1 stuff. Okay, and I see that infinitely many of these terms all vanish due to at least the factor of x. So the lone survivor is 1 at the very beginning. Okay, so this confirms that the function has to be continuous at x equals 0. And what does that tell us numerically? Numerically, it tells us that when you calculate this expression for x small, okay, meaning close to 0, they have to get closer and closer to 1. Okay, but numerical experiment shows that that's not the case. We've certainly seen that in the previous homework, and you'll see this in this homework as well. But yeah, so this is the only part that is essentially different from the previous version of this problem. Yeah, over here, you just need to do what it's telling you to do. Calculate f of x as written over here. Calculate it in the equivalent, in this different but equivalent way. Analytically, it's equivalent, identical. However, numerically, it's different. Okay, so please try that. And lastly, MATLAB has a built-in function called log 1p, and this calculates log 1 plus x robustly, in a very robust fashion. Okay, so if you type help log 1p, that means log 1 plus. Okay, it computes log of 1 plus x without computing 1 plus x for small x. Okay, so what it means is that if you do say log of 1 plus x in MATLAB, what it's going to do is it's going to compute 1 plus x first and then compute log. Okay, So log is one of the built-in mathematical function in MATLAB, but the library, the code is not accessible, is part of the library that I don't think is accessible. So type log. It's not going to tell us any details, any of these gory details of how log function is computed in a stable and efficient manner. Okay, but what essentially it does is it uses Taylor series expansion of logarithmic function to calculate the log function. Okay, so that's something that we need to keep in mind when computing, when evaluating these functions in computers. Except for addition, subtraction, multiplication, and division, functions like sine or cosine, exponential, and logarithmic functions, these have to be somehow calculated in terms of basic operation, addition, subtraction, multiplication, and division. And that's why their Taylor series expansion or some sort of series expansion is used under the hood. Okay, so in the case of log, the Taylor expansion of log will be used. Okay, and in that process, this number will get subtracted. MATLAB will subtract 1 from this number. Okay, and for x small, that subtraction causes so-called catastrophic cancellation, and that's why you are going to see nonsense answer. Okay, so in order to avoid such nonsense, this is one way to bypass such catastrophic cancellation. Okay, so yeah, I'll leave the details up to you to figure out. You'll have to work it out for this, but I will actually provide you with the write-up written solution for this particular version, so you can use this to you can use that as a basis for the actual homework problem. Okay, so that's problem number 4.